Meet Maya. She's working on a science fair project. She's collected data on how many hours students study versus their test scores. She's got a chart full of dots and no idea what they mean. Sound familiar? Well, by the end of this video, Maya and you will know exactly how to read scatter plots and spot trends like a data detective. Let's dive in. So what exactly is a scatter plot? It's a special kind of graph that uses dots to show how two things relate to each other. The horizontal axis, the x-axis, shows one variable. The vertical axis, the y-axis, shows another. Each dot on the graph represents one data point. Maya's dots show one student each, how many hours they studied on the x-axis, and their test score on the y-axis. Every single dot tells a story. Maya starts plotting her data. Student A studied 2 hours and scored 60, so she places a dot at the coordinate 2, 60. Student B studied 4 hours and scored 75. Dot goes at 4, 75. Student C, 6 hours, score 88. Dot at 6, 88. And student D, 8 hours, score 95. Dot at 8, 95. Maya steps back and looks at her 4 dots. She notices something. They seem to go up as you move right. Something interesting is happening here. Look at Maya's dots. They travel from the lower left all the way to the upper right. This pattern has a name, a positive trend, also called a positive correlation. It means that as one variable goes up, the other goes up too. More hours studied leads to higher test scores. Here's an easy way to remember it. Think of a thumbs up. When both values rise together, it's positive. You'll see positive trends everywhere in real life. Now, here's where it gets really interesting. Not every trend goes upward. A negative trend means that as one variable increases, the other one decreases. Imagine tracking how many hours of TV students watch versus their test scores. More TV time, lower scores. The dots would go from the upper left down to the lower right, like a slide going downhill. We call this a negative correlation. Think of it as a thumbs down. One goes up, the other goes down. But wait, sometimes the dots are just scattered all over the place with no clear pattern going up or down. That means there's no correlation, no relationship between the two variables. For example, does your shoe size affect your math test score? Probably not. The dots would be totally random. Maya learned that just because two things are on a scatter plot doesn't mean they're connected. That's an important lesson in data. Always look before you conclude. Let's work through Maya's actual scatter plot. Here's the data. The more hours students studied, the higher their scores. Looking at the graph, the dots climb from the lower left up toward the upper right. There's a clear upward path, a positive trend. We can even draw a line of best fit right through the middle of all those dots. Since study hours go up and scores go up together, this is definitely a positive correlation. Maya's science fair project is coming together. Now let's look at a different data set, TV hours watched versus test scores. Starting at the left side of the graph, students who watch just 1 hour of TV score around 92. Moving right, a student watching 3 hours scores about 80. At 5 hours of TV, the score drops to 70. And at 8 hours of TV, the score falls to around 55. See how the dots are traveling from the upper left down to the lower right? As TV time increases, scores decrease. That's a clear negative trend, a negative correlation. Here's Maya's third scatter plot, shoe size versus test scores. A student with size 5 shoes scores 78. Size 6 shoes, score is 65. Size 7 shoes, score is 90. Size 8 shoes, score drops to 55. Size 9 shoes, score jumps back up to 88. Do you notice anything? The dots are jumping all over the place, up, down, scattered randomly. There's no pattern here at all. No trend line fits nicely through these dots. That means there's no correlation. Shoe size and test scores have nothing to do with each other. Phew! Ready to test what you've learned? Let's think through some real-life examples. Temperature versus ice cream sales. As it gets hotter, people buy more ice cream. That's a positive trend. Age versus reaction time. As people get older, reaction time often slows down. Negative trend. Practice hours versus free throws made. More practice means better shooting. Positive. And what about height versus favorite color? There's no connection there. That's no correlation. Maya is flying through these now. Are you keeping up? Here's a bonus insight. Not all trends are equally strong. When the dots cluster tightly along the trend line, the correlation is strong. When dots are more spread out but still show a general direction, it's a weak correlation. Real-world data is messy. You almost never get a perfect line. Maya noticed that her study hours data had a strong positive trend because the dots were close together. The TV data? Also fairly strong negative. Your job is to identify the direction and judge the strength. You're becoming a real data analyst. Maya finishes her science fair project with 3 clear scatter plots and real conclusions. She writes, "Studying more is positively correlated with higher test scores. Watching too much TV is negatively correlated with scores. And shoe size? Totally irrelevant." Her teacher is impressed. Maya didn't just collect data, she analyzed it. She spotted the trends, drew the lines, and made real conclusions. That's exactly what data scientists and statisticians do every single day. And now, you can do it too. Let's wrap it all up. Remember when Maya was staring at a page full of confusing dots? Now she and you can look at any scatter plot and identify the trend. Positive correlation means both variables rise together. Dots climb up to the right. Negative correlation means one rises as the other falls. Dots slide down to the right. No correlation means no pattern at all. Always look for direction and strength. You've gone from confused to confident, just like Maya. Keep practicing and you've totally